And now I'm happy to give the floor to Andrzej Arshavsky, head of Data Monetization Center of Gazprom Neft, who is going to talk to us about AI applications in industry, advances and barriers that exist in this relation.
Good afternoon, colleagues. I am Andrzej Arshavsky, and I will tell you on how we implement AI technologies in Gazprom Neft. What are the hurdles, the stumbling blocks, and how we overcome them. At first, I would like to tell you about projects we do and what for. So the strategic goal is
to use the data analysis and digital twins to make the decisions in the company all along the value-added chain. That is why we do not focus on one area of our business, but we look at it from the source of our business model, like oil exploration and development, to the end points of our business, that is logistics and sales. So we work all along technological processes, and we cover legal functions, economic, procurement, and other supply functions. Our task, thanks to AI and data analysis, is not simply to make our company more efficient, but more manageable and safer in terms of industrial safety and the risks that we carry in business application. And for that, we have several areas working on AI and several areas aimed at making data an asset of the company, making data accessible, and providing tools for data analysis and data processing. We are implementing dozens and hundreds of projects based on data and mathematical modeling. And though we focus on the whole chain, value-added chain, the majority of our projects focus on the first stages, because that is where the majority of our expenses go. And I'm talking about exploration and development. And today I'm going to talk to you about how we develop and support the development of AI solutions. And I will give you a couple of examples of projects with the AI that are up and running on our side. So the first example is a product with the help of which we can forecast lithology, that is geological rocks and geological layers that will be met by us while drilling. And I must say that drilling process is really high-tech and really complex. And we have to work at depths of several kilometers. And the drilling process itself moves not only vertically, but horizontally as well. And there can be different complex configurations of drilling. While drilling, we gather information from sensors that are close to the drilling bit, but not on it directly. And our task is to get this logging information from sensors that signalizes about magnet data on the rock and other measurements. And that is used to forecast the rocks at the distance of 10 to 30 meters from the drilling bit, so that we stay within the targeted layer of the drilling. And thanks to historical data on drilling, we were successful to build this forecasting model, and we managed to cut deviation from the target drilling. This product is now at this stage of commissioning, and it has been tested at several fields of ours, and we are going to commercialize it and sell it at external market. Another example is a system that assesses efficiency of the so-called critical operations on enhanced oil recovery. And here, that is when the development cannot be that effective at the fields that have been up and running for much time. And special tertiary or EOR methods are used when special chemical mixtures treat the well, and naturally it costs money, and therefore we use historical data and mathematical models to see and to be sure that chemical treatment of this or that well will have positive results in terms of oil recovery. And this historical data and mathematical modeling has proven successful on our end. And for that, one or several models is usually used, and very often optimization contours are absent, but in the majority of cases where solutions are introduced, the structure of the project is more complex. As we have dozens and hundreds of projects with AI, as I have said, we naturally meet certain barriers. We have classified them and would like to share this classification with you. One of the major barriers is the insufficiency of the team role model. Because the classical team role model that is comprised of data scientists, data engineers, project leads, is not enough for complex technological AI projects. Another role is needed here, and we will speak about it a little bit later. Apart from these barriers, naturally, we face a barrier of access to high-quality personnel, including data scientists as well, and including possibility of knowledge, capabilities and knowledge and personnel that has to make decisions and provide support in decision-making. We also see drawbacks of technological character that stood in the way of our successful work and operating work with models. Naturally, a large class of barriers is connected with the need to solve tasks that do not have large data arrays or learning samples. So we need to learn on small amounts of data. And that is accounted for not only by the fact that not many data are accumulated, but also by the changes in technological processes or the environment that we have to work in. In our case, in case of oil development, we very often face the situation when in new oil fields, the old methods do not work, and we have to adapt to new conditions, learning on pretty small amounts, small volumes of data. And new equipment cannot be used effectively, or equipment cannot be used effectively in new conditions. That is very often happens as well. A typical project, AI project, is not just a separate model learned on historical data. As a rule, we take a decision on whether to develop or not to develop an oil field, what technological operations we need to use for EOR, how to manage a fleet of pumps operating in this or that oil field. And as a rule, the solution is a set of models. That can be dozens of models and optimization contours. And this is a set of limitations, restrictions, and rules, and a system of decision-making support that can filter out some invalid or hazardous operations. And both operating and historical data set come up with a certain recommendation as a result. And a large team of experts have to work on it. A large team of data scientists have to work on that. And for them to do it effectively, as we have said and heard many times, that it is not enough to just be a data scientist. You need to program, develop, and communicate. You have to communicate with all the levels, with technicians, with task setters, and so on and so forth. If we talk about data scientists' tasks in banks or internet companies, there they have to perform pretty clear, I would say, or easy to understand tasks, maybe typical tasks, such as customer retainment, advertisement, targeting, offer targeting, risk assessment. So these tasks can be simply counted by the fingers of two hands, and they are pretty clear to understand. And these people are communicators. They are within the social environment. If we talk about production companies, that is a totally different context. Every task is unique, and it needs getting into the picture. It even needs special education and training. For example, the task of drilling or field development or oil refinement requires a separate education, even degree, that takes people several years to receive. And how can we deal with that situation? Should we teach the production people how machine learning models work? Should we get them into the team of data scientists so that they can share their knowledge with the data scientists? Yes, this is possible, but as a rule, it does not work effectively because these experts and data scientists speak different languages. And as data scientists have mathematical mind, they are capable of getting into the technological process, but they do not always have time for that. Therefore, we, as people that work with technological processes in production company, long ago saw that we needed a separate role, the so-called technical analytics data scientist. And we believe that this role will receive data scientists mainly that will devote their time to get into the technological process that they automate thanks to data science. And they will be task setters for data scientists, ordinary data scientists, and they will also perform a monitoring and supervision function in terms of what data scientists do, because their decisions can be non-viable because of their negligence to this or that restriction or limitation, because they simply do not have time or they cannot communicate with technical experts. So we have described this role in detail, and we have called it Technical Analytics Data Scientists, TADS, as I have told you. And we are planning to come up with a state standard, a state educational standard on this position. And we have determined its role in different stages of the project. And here you can see first two stages, that is selecting, choosing ideas, and R&D. And on the next slide, we will have details of prototypization and MVP and production or products of the solution. So here we describe the role of technical analytics data scientists, the actions of product owner in the team, and the actions of a project manager and data sciences and development team. And we can see that technical analytics data sciences has really many tasks to perform at the choosing ideas stage and R&D stage, where technical analytics data science has to analyze all the conditions, limitations, and requirements, and also develop the program and methods of tests and economic effect that can take place through algorithms in a pretty complex way. And they also help communication. They help to smoothen communication between the other members of the team. At the prototype stage, technical analytics data scientist is also involved and engaged, helping with technical documentation. Because solution development using AI requires additional documentation for all the participants of the team, including data scientists, to understand each other very well. And there's a responsibility for drafting these documents aimed at informative level, high informative level, belongs to technical analytics data scientists. Well, data scientists also take part in this drafting documentation, but the responsibility is with the technical analytics data scientists. At MVP stage, the methods of testing are elaborated, and it is all elaborated with the technical team that will be the end user of the solution. And after the introduction, TADS is responsible for designing the development of the product and programming the line of support and consultations of the second and third line of support. And TADS are the main carriers, so to say, of knowledge of what has to be done. At every stage of the project, according to our classification, so choosing ideas, R&D, prototyping, MVP, and product development, well, all the stages take part from 3 to 6 months. And as a result, there has to be program code formed and documents that describe tests, approaches, hypotheses, models, how they were elaborated, what their accuracy is, what proved to be successful and what not. So therefore, there is a certain set of documents with a code, a description of a code, a description of data, an analytical note, which is a key document. So technical analytics data scientist is responsible for the documentation that belongs to the task connected with the data analysis and analytics. And this documentation is important for further development of the project and when the project is implemented by the subcontractors and then is given to contractor. The documentation naturally helps when the subcontractors are found, and it helps to make a decision of understanding what has been made, and it helps to move from one stage to another. When certain difficulties turn up, it helps to make unbiased and well-elaborated decisions, bearing in mind all the stakeholders. And you can have a look at the examples of the documents, and we have them in open source. And we share this all openly, and we call upon other companies, including technological ones, to join in to perfect this methodology, to develop it further on. And a couple of words about the fact that the platform that we are elaborating inside the company supports it all. It is aimed for supporting ML solutions development, and it is based on open technologies, and it helps us in our operations. Both the methodology and solutions are elaborated by us together with the leading scientific teams of the country, including Skoltech and St. Petersburg, our educational institutions like Gazprom and Polytech that helped us in methodology and verification, and also in getting personnel for solution development. Thank you very much for your time and attention, and I hope that my presentation was useful.